Hi students. So let us consider the open loop transfer function of a unity feedback system with negative feedback is given by this open loop transfer function. Now we are asked to find the value of k such that the closed loop poles has real parts more negative than -1, meaning we don't want the poles to be going anywhere close to the imagined axis, because we know that as the poles go to imagined axis, then the system overshoot will increase, then the system will take a lot of time to settle down, all those stuff. So that's why we want to find the value of k such that closed loop poles are more negative than -1. So we know that the characteristic equation can be written as this, and for this transfer function the characteristic equation is this. So maybe we can find the equation, the polynomial of this one, so that we can write the Routh and proceed with this. So now this is what is, so I can write it as s plus 2 into s plus 4 into s plus 6 plus k equal to 0. This happens to be s square plus 6s plus 8 multiplied by s plus 6 plus plus k equal to 0. This will become s cube plus 6s square plus 6s square plus half, 36s, and then this is 8s plus 48. Of course plus k is there. So this characteristic equation now reduced to s cube plus 12s square plus, so now this happens to be 44s plus 48 plus k is my characteristic equation. Suppose if I write the Routh and find k margin, so what I'll get is I'll get the value of k such that poles are there. Okay, let me just do that. So there is no harm. Suppose if I do that, this is s cube, this is s square. So the other elements are 1, 44, and this is 12 and 48 plus k. S power 1 happens to be 12 into 44 minus 48 k by 12. This is 0. Then s power 0 is 48 plus k. I can actually find the k margin by equating this to 0. That is, so 12 into 44 minus 48 plus k is equal to 0. Then this becomes k margin. Sorry. Then k margin becomes 12 into 44 minus 48. So how much is this? Sorry for that. 12 into 44 minus 48 is actually 480. K margin 480. What does this indicate is, this indicate the value of k is between 0 and 480. All the poles are there to the left half of the S-plane. But there is no guarantee that I don't know what is the value of k such that it is less than -1. If the value of k is less than 480, then it is true that all the poles are there to the left half of the S-plane. So to find the value of k such that closed loop poles have the real part more negative than -1, I have to replace all s by s minus 1. Let me replace s by s minus 1, then this become s minus 1 whole cube plus 12 into s minus 1 whole square plus 44 into s minus 1 plus 48 plus k equal to 0. So then this will be, I know that a minus b whole cube is s cube minus, of course it is 3 a square, b is 1, then plus of 3ab square. ab square, okay, b square is 1 here, so it is so and so, minus of 1 square. 1 square is 1. So this is what is, so we know that a minus b whole cube is actually a cube minus 3a square b plus 3ab square minus b cube, which will be, so here I have it as whole cube. So in place of a you have s, in place of b you have 1, so it is minus 3a square and it is plus 3, this is s, and since it is 1, fine, so it is minus 1. So this is what we have. So you have it as s cube minus 3a square plus 3s minus 1. So this is 1, then it is 12 into a square plus 1, okay, sorry, a square plus 1 minus 2s is this, then it is 44s minus 44 plus 48 plus k equal to 0. Then this is s cube plus this is 12 minus 3 is 9 s square, then it is, what will be the value of s here? So it is, so you have 44 minus 24 is your s, minus 24s and plus 3s, so it comes out to be plus 23s plus, so what will be the s power 0? It is minus 1 plus 12 minus 44 plus 48. It has to be 15 plus k. So this is my modified characteristic equation by replacing s by s minus 1. So is this fine? Hopefully this is s cube, this is minus 3, you have minus 3 plus 12, okay, that is 9, then you have 3 here, then it is minus 24 here, then it is plus minus 24 plus 44, that's what is 23s, then it is minus 1 plus 12 minus 44 plus 48, 15, okay, this is what we have. This is s power 0 quotient. So let me find the roots array for this and k margin. So it is s cube plus 9s square plus 23s plus 15 plus k. 15 plus k equal to 0 is my characteristic equation. Let me just do this here. Now if I do this, so what is this now? Is this not s cube s square? Is it not 123? Is this not 9 15 plus k? So what is s power 1? It is 9 into 23 minus 15 plus k into 1 by 9, then it is 0. S power 0 is 15 plus k on 0. So to have this term as 0 to get the auxiliary equation, so now what is this? 9 into 23 is equal to 15 plus k margin. Therefore k margin is equal to 9 into 23 minus 15. See, it's 190. So this is 192. So what does this mean here? This is K margin by replacing S by S minus 1. And when the S was as it is, the K margin was 480. So when this was 480, I had the poles at minus 2, minus 2, minus 4, minus 4 and minus 6. So these were the pole positions. So this is minus 2. Actually how it went, so this was going like this, and of course in terms of root locus, if you want to find out, it was actually going like this. This value of K was 480 and we were looking at minus 1 as the real part. Now we are actually finding what is this value of K. So when the value of K, which corresponds to a real part of minus 1, for that it is 192 is the value. So that you can just slightly verify that in your 20 sim. So let me just see. Okay, it's here. So 20 sim is here. So let us verify. This is how you want to do it. If you want to find what is the value of K such that poles are more negative than minus 1, so whatever is the value that is given, replace that S by S minus 1. Suppose if you want to have more negative than minus 0.5, just make it as S, wherever S is there, replace it by S minus 0.5, and whatever the power you have, just retain that. Simply replace that S by S minus 1 or whatever the real value that you want to have here. So let us see what will get here. So now let me close this. It will come. Okay, now let me insert the submodel linear system. So I have my, okay, let me delete this. Let me add pole at minus 2. Let me apply one more at minus 4. Minus 4 I'm applying. Oh, I have to add. One is at minus 2. So let me add one more at minus 6. Let me apply now. So all the three are there. Let me just close this, plot this. So let us have a look at the value of K. See now, the value of K is somewhere here. You can see it is 334. It's here. So I cannot place it exactly this point. So that's a disadvantage. You can see now it is 637. So now the poles have gone to right hand side, and this is exactly 480 as per your calculation. That will be so. Now we are looking at when it is minus 1, what is the value here. So let me see, can I able to bring the pole here? You can see now here it's almost close to minus 1. Can you see it is 183? So this is 183 and you have it as slightly, it is slightly towards minus 1.04. So we actually have it as 192 as the value. So it is still more negative than minus 1. It's, if it is exactly minus 1, then the value of K will be 192 as per this. So as per our calculation, this happens to be 192. What does it actually mean is, when the poles have to be more negative than this minus 1, if the poles have to come on the left hand side of this, the value of K should be less than 192, less than 192. The another confirmation of this is actually what we are trying to do, why we are replacing that S by S minus 1 is. So let me just clarify that. See here, we have replaced S by S minus 1. So S by S minus 1. This is actually trying to make this imaginary, so whatever axis you have here, instead of putting it at this point, let us shift it to a new point where it is, where this is at minus 1. When you're shifting this to this, so when this minus 1 becomes origin, so what will be this value? This minus 2 will become minus 1, this minus 4 will become minus 3, this will become minus 5. Meaning, when this imaginary axis shifts towards the left by 1 unit, this was minus 2 when this is the imaginary axis. When the imaginary axis shifted by 1 unit, so being okay, these poles being at the same point, then this position becomes -1, then this position becomes -4, this position becomes -5. So they are actually reduced by 1 unit. So what is the new characteristic equation now? So shall I now write the new characteristic equation with the shifted shifted closed, sorry, the imaginary axis is it not s plus 1, is it not s plus 3, is it not s plus 5? If I find the k margin for this has to be 192. So why this has to match with this? Because now it's the same transfer function what I had. Instead of replacing s by s minus 1 here, instead of replacing s minus 1 in this characteristic equation, what I'll do is I'll change the pole position of my original transfer function by replacing s by s minus 1. Suppose if I replace this s by s minus 1, so what I'll do, so I will make this by s minus 1. Is it not s minus 1 plus 2? Is this not s minus 1 plus 4? Is this not s minus 1 plus 5? S minus 1 plus 5. So sorry, 1 plus 6. So what is this now? S plus 1. This is minus 1 plus 2. It's s plus 1. So what is this? S minus 1 plus 3. Is it not s plus 3? So what is this? S minus 1 plus 6. Is it not s plus 5? So I have s plus 1, s plus 3, s plus 5 is my transfer function. If I solve for this, the k margin, it has to be 192. It has to be 192. So that's why we are replacing, instead of replacing it here, we are replacing it in the characteristic equation s by s minus 1. So let us prove that for this transfer function with the shifted imaginary axis by 1 unit, the k margin should be 192. So what is this now? It's now s plus 1 into s square plus 8s plus 15 plus k equal to 0 is my characteristic equation. Is it not s cube plus 8s square plus 15s plus s square plus 8s plus 15 plus k? Is it not now s cube plus 9s square plus 23s plus 15 plus k equal to 0? Just compare these two. See now, earlier I had this as my characteristic equation replacing s by s minus 1. By replacing s minus 1, I had this characteristic equation. Can you just see here? Are both of them same? This is the characteristic equation replacing the characteristic in the characteristic equation s by s minus 1. Now this is the transfer function. This is the characteristic equation by replacing s by s minus 1 in the pole position. So now I have this as the characteristic equation from replacing this s by s minus 1. You have this as the transfer function. This is the characteristic equation. Can you see, is it not 100% the same? 100% the same. Can you see it is s cube, 9s square, 23s, 15 plus k. So these two are same. What I mean to say is, if you know the closed loop pole, sorry, if you know the pole position, if you want to find out the value of k such that poles are more negative than -1, here itself you can replace s by s minus 1. Suppose if you don't know the pole position, if you know the characteristic equation, then you have to replace s by s minus 1 to get a new characteristic equation which corresponds to the value of course, if you find the value of k here, this value of k is corresponding to the value of k which will have its real part. The closed loop real parts will be more negative than -1. More negative than -1. So this way we can able to find out the value of k such that poles are more negative than -1. So let me just give you one example in the textbook. So it says, or it will ask for equation s cube plus so this is my characteristic equation. So in this characteristic equation we are asked to find the value of k such that it is the closed loop poles are more negative than minus 1. So for which I have to replace this s by s minus 1 whole cube, replace again this s by s minus 1, because I don't know where the poles are, because I have been given a characteristic equation. Because in the previous problem we started with the open loop pole position, we obtained the characteristic equation and then we substituted s by s minus 1 and then we could able to write the modified characteristic equation. But here the characteristic equation is given, we are asked to find the value of k such that closed loop poles are more negative than minus 1. So you have to straight away go here, replace s by s minus 1, then it is 7k plus 5 into s minus 1 plus 4k plus 7 equal to 0. So now I leave it to you people, find the value of, expand this each term, write the new characteristic equation, then write the Routh's array and look for the value of k for which system is stable. So you will end up with a auxiliary equation. You find out for what value of k system will be stable. System will be of course not stable, more negative than minus 1, because you are looking for this minus 1. Hope we will do it. So maybe in the next video we will check the value of this. So we'll just go through the solution for this.